Hello, my name is David Hynd and I'm Chief Scientist for Vehicle Safety and Investigations at TRL, the UK's Transport Research Laboratory. Today I would like to talk about the RAID's in-depth collision investigation work that we do in collaboration with hospitals, coroners and the police. Both how we gather the data, technically and ethically, and how we use that data to support meaningful reductions in road traffic casualties. First, I would like to start with a quick introduction to TRL. TRL is an independent scientific research organisation with around 250 employees. Together, we share a vision of clean, efficient transport that is safe, reliable and accessible for everyone. Our work to realise this vision is focused around the 6 strategic themes shown here. Okay, so what is RAIDS? RAIDS is the Road Accident In-Depth Studies. Managed by TRL on behalf of the UK Department for Transport, RAIDS is one of the leading in-depth collision investigation databases globally. The aim of RAIDS is to provide detailed evidence on the causes and consequences of road collisions in order to improve road safety outcomes. In-depth studies provide an opportunity to understand how crashes and injuries occur, and from this understanding contribute to the development of safer roads and safer vehicles. Detailed information is collected about the crash site, including highway features and environmental factors, and vehicle damage can be matched to the injuries received in the crash, allowing an understanding of how vehicle design can be improved. We collect a very wide range of information about collisions. We collect information about damage to the vehicle, both inside and out. This helps us to understand how vehicle structures manage the huge energies involved in a collision, and how contact points with occupants and vulnerable road users relate to the injuries sustained. We collect information about the scene of the collision, the nature of the road layout, roadside objects, environmental conditions, and so forth. This helps us to understand how the collision occurred and what could be done to prevent it happening in the future. For example, this can be used to estimate the effectiveness of new collision avoidance technologies or better standards for roadside furniture, such as lighting columns or signage. We collect information about each injury sustained by those involved in a collision. This is correlated with the detailed vehicle information to understand and improve the effectiveness of restraint systems, such as seatbelts and airbags, as well as vulnerable road user protection systems. And lastly, we send questionnaires to many crash participants. These could give additional information on collision circumstances and injuries. In total, well over 3,000 fields can be collected per case, which inform a wide variety of road safety studies. So where do we collect this information? We attend the scene of collisions in Thames Valley and Hampshire police locations that were within 1 hour of TRL. These are shown on the left. We also inspect recovered vehicles across a much larger area, that's shown on the right. Well over 2,000 collisions have been investigated during the programme so far. To achieve this, RAIDS relies on cooperation with many people and organisations. We work with Thames Valley and Hampshire Police and have a seconded police officer embedded in the RAIDS team. We have agreements with 21 hospitals at 11 trusts and have sent nearly 2,500 requests for anonymous injury information to hospitals. We also have similar agreements with 5 coroners' offices and have sent over 300 requests to coroners for anonymous injury information. We've also sent over 3,000 questionnaires to people who are involved with collisions. So I'd like to take the opportunity to give a big thank you for all of those who make this life-saving study possible. RAIDS operates to very strict ethical and information security standards. RAIDS has Section 251 approval to support access to anonymous injury information at hospitals, and this is absolutely fundamental to the study. The Section 251 approval rests on approval from an appropriate NHS Research Ethics Committee and maintenance of the DSP toolkit approval. We have information sharing agreements with police, hospitals, coroners and other organisations, and strict protocols for how we collect, process and store different types of information. We have highly segregated roles within the RAIDS team. Collision investigation, coordination of injury information requests, injury coding and so forth are conducted by entirely separate staff. We have regular information security checks and training specific to the RAIDS study. Together, these controls are designed to ensure anonymity for crash participants and preserve the integrity of the database, and also to ensure that the study is conducted to approved ethical standards at all times. So that's a little bit about RAIDS and how it works, how we ensure a fully anonymised in-depth collision database that can answer key road, vehicle and road safety questions. But what is it used for? RAIDS data is available to experienced road safety researchers on application to and approval by the DFT. Well over 100 studies have been approved to date, including studies by car manufacturers, road authorities, insurers, researchers, the European Commission and academia. These have led to improved vehicle designs, better child restraints, recommendations for improved roadside barriers, improved crash test procedures and many, many other advances. I'm going to mention one study in particular, which is updates to the Pedestrian and General Safety Regulation. This is a large programme of work that TRL has undertaken over the last 7 years or so for the European Commission. I should probably start by saying what the Pedestrian and General Safety Regulations are. These are the core legislation that sets vehicle safety standards in Europe for cars, vans, trucks and buses, so motorcycles and other vehicles are considered separately. Where possible, new regulation is achieved by referencing UN regulations agreed globally at Geneva. If a suitable UN regulation is not available and not in development, individual legislative requirements are created at the European level and incorporated in the GSR and the PSR. The Commission periodically reviews the need to update the regulations to reflect technical progress in vehicle safety. The most recent review kicked off in 2014 and TRL were contracted to support this process. I won't go into the specific applications of RAIDS data within the programme, which are numerous, and essential to inform the casualty reduction benefit estimates that were used in the programme, with case-by-case studies of the potential for different technologies to prevent or mitigate the outcome of each relevant collision. Instead, I will give you a brief overview of the programme and the predicted casualty savings resulting from that analysis. And just to note, at all stages of the programme, we consulted extensively with vehicle manufacturers, suppliers, governments, researchers and NGOs to ensure that the best available evidence was used throughout. And we also generated new evidence based on RAIDS data where necessary. So in the first part of the programme, we looked at over 50 candidate implementing measures, basically regulations, covering active safety, so collision avoidance systems, car occupant and pedestrian secondary safety, so how to mitigate injuries if a collision does occur, crashworthiness of vehicles, heavy goods vehicles, fuel system safety and so forth, as well as driver interface, driver distraction and intelligent transportation systems, so systems designed to support the driver to operate the vehicle safely. For each of these 50, we looked at the definition of the problem, so what was the casualty problem that this was aiming to solve, and agreed a definition of each of these with all of the stakeholders. We looked at the potential mitigation strategies, the feasibility for these strategies, so that's at two levels. One is it technologically possible to mitigate either the collision happening in the first place or the injuries that occur as a result of the collision? But also, is it feasible to implement a regulation? So it might be that there is a technology available that can be used, but nobody yet knows how to define a regulation that can require manufacturers to fit that technology. We looked at the costs and the benefits and developed an indicative benefit to cost ratio for each of the measures in isolation. As a result of that, 24 measures were taken forward into the next stage. So we whittled down to approximately half of the candidate measures and proceeded to look at the most effective measures going forward. So one of the key considerations for the next stage was that there was the potential to implement multiple regulations at the same time. So looking at the cost benefit of each in isolation wasn't appropriate. We needed to ensure that we were looking at the effects of the entire package of measures that could be considered, and ensuring most particularly that we didn't double count casualty savings. So it could be that a particular casualty would be saved by an active safety measure and a passive safety measure, and we don't want to count those twice in the cost benefit analysis. So we built a pretty complex cost benefit model that looked at different layers of technology that could be considered. So the first was looking at electronic stability control, which is already required by regulation, but which doesn't yet have 100% fitment in the fleet. So a number of casualties across Europe will be saved by continued application of ESC and continued fitment in compliance with the regulations. We don't want to count those in the benefits for the potential updates to the pedestrian and general safety regulation. We then looked at driver assistance systems, such as intelligent speed adaptation, alcohol interlocks, and other technologies, and accounted for the interactions between those technologies and what the resulting casualty population across Europe would look like. For that remaining casualty population, we then looked at the potential for active safety systems, so automated emergency braking, lane keep assistance, and so forth, to help prevent collisions occurring in the first place or to reduce the severity of collisions. And that again results in a new casualty population. And we then look at the effect of potential passive safety measures, so improved frontal impact or side impact crash protection, for instance, to reduce the number of casualties and reduce the severity of injuries occurring to those casualties. And we look at the benefit to cost ratio for each measure as part of a package. So we had lots of different candidate regulations within that cost benefit model, and we combined these into different policy options. So we looked first at policy option 1, which was state-of-the-art and widely available systems in the market. So systems that were already available in cars, and voluntary fitment by manufacturers was somewhere in the range between 5 and 90% of the new car market. Policy option 2 was the same as policy option 1, but with additional vulnerable road user and driver attention systems. And finally, policy option 3 was policy option 2 with all remaining feasible measures. So these policy options were presented to the European Parliament and the European Council and debated widely, and both the Council and the Parliament voted for policy option 3, which was the full set of all feasible measures. So just to have a look at what that looks like in terms of number of regulations and the vehicles to which they apply. Policy option 1, at the right hand side here we have M1, which is cars, M2 and M3 is buses and coaches, N1 is vans, and N2 and N3 is heavy goods vehicles. So you can see that the coverage for the policy option 1 was a little less than half of the different vehicle combinations and technologies that were being considered. And look at vehicle policy option 2, and finally policy option 3, which is all combinations of vehicles and technologies. And this is the one that the Parliament and Council voted for. Over the subsequent 2 years, we supported the Commission in drafting some of the regulatory requirements shown here, and most will be implemented from July this year across Europe. I should note that the UK government has yet to decide whether to implement the new requirements in Great Britain. So what does this mean for road safety? Well, the cost-benefit model for the full package of regulations being implemented this year predicts a saving of nearly 25,000 fatalities and 140,000 serious injuries across the 16-year evaluation period. That's 25,000 fatalities saved. This is only possible due to the in-depth analysis that can be performed with data such as RAIDs. So again, a big thank you to all those who continue to ensure that this data can be collected and used to reduce the totally unacceptable number of people killed and seriously injured on our roads. Thank you. And thank you for listening.